Hello everyone, back tuning into today's video. It's a big update for today's video because we're doing the first winter 2017-2018 update today. So this is one you've probably been waiting for. Between now and the end of November, we're going to do winter updates every Sunday or season model roundups. There'll be 3 of those between now and the end of November, building up a picture on a week-by-week basis to see what might happen for the winter of 2017-18. And then, at the end of the updates, we get to start of December, we will release the GazWeathers.com winter 2017-2018 forecast. So all of these updates are building up a picture, if you like. I sort of liken it to creating a painting. So we start with a blank canvas, and on a week-by-week basis, we gradually add more and more and more to the canvas until eventually, if everything's working correctly, we should get a picture emerging that points us in the direction of where things are going to go for the winter of 2017-2018. And when we get to the end, that's when we release the forecast. So, for today's video, I'm not able to sit here and tell you, yes, it will definitively be a colder than average winter, or I'm not able to definitively sit here and tell you it will be a milder than average winter. That's not how GazWeathers.com long-range forecasting methodology works. There are forecasters that are able to predict the seasons many weeks and months in advance. So there are forecasts out there right now for the winter 2017-2018, and good luck to those forecasters that do it, but I'm not able to do that. My methodology doesn't work like that. I like to sit back and build up a picture, see where the methodology is going, and eventually we get to the forecast at the end of the season. Now, at the end of this first update, I will give you the date when we're going to be releasing the GazWeathers.com winter 2017-2018 forecast. Will be coming up right at the very end of this video. But got a lot to discuss before we get through that. We're going to look at the oceans. We're going to look at hurricane activity. We're going to look at what's happening in terms of Arctic sea ice. We've got lots of analogues to have a look at as well. So I think we better get on with it very shortly. Just say it's going to be a long video. All these winter updates are always over half an hour. So it's going to be a long video. If you can't watch it all you want to go, don't worry. It's going to be kept at the website indefinitely. You're probably watching this on the homepage right now, but later on today, this will be placed on the winter updates and forecast page. There'll be a written report that goes with it as well. So you can't watch the video when you want to go. You can come back and watch the video when you want. And also, of course, you're able to read that written report. Okay, we better get on with the first update then. So we're going to begin by having a look at the oceans. 2 oceans specifically that we're interested in being the Atlantic and the Pacific Ocean. So let's deal with the Pacific first of all. We're interested in the equatorial part of the Pacific Ocean, what's happening there. So this is the ENSO region from Peru, which is over in South America, just there, to Indonesia over here. When we get warming and cooling of the equatorial Pacific Ocean, that is ENSO state, if you like. And ENSO state is usually the main background driver for the global sort of weather system. When it warms, we have an El Nino. When it cools, we have a La Nina. Now, we appear to have a signature for a La Nina at the moment, actually. We are seeing cooling taking place across the equatorial Pacific Ocean, quite interestingly. We aren't in a La Nina yet. We aren't in a La Nina at this stage, but it certainly looks as though that might be where the equatorial Pacific Ocean is trending to. Now, further north, this is quite an important region up here in the northeastern part of the Pacific Ocean. When it's warm up here, and it has been warm up there over the past few winters, when it's warm up there, it seems to be something that can be quite closely associated with cold air coming down with a northwest-southeast trajectory jet stream into Canada and northern parts of America. When you get cold air coming down there, it can tend to blur cyclogenesis in the eastern part or I should say in the western part of the Atlantic Ocean. And and that cyclogenesis can then get involved with jet stream, blow up the jet stream, and we can deliver big areas of low-pressure stormy systems into the Atlantic and Northern Europe. This is normally quite a cold place, but over the past few years, it's been pretty warm up here. We'll have to wait and see where that's going to go. At the moment, the temperature anomalies up there are quite close to average. But if you want a cold winter, I think you want to be seeing this. If you want a cold winter in the UK and Europe, I think you want to be seeing this cooling down. Whereas if you want a cold winter in America, having it warm in this area can be quite useful. Now, over in the Atlantic, we've got some interesting developments. We've got a very warm area just here in the tropical part of the Atlantic Ocean. Now, this year, this area just here is turning out to be kind of like the breeding ground for tropical storms and hurricanes. We are in the middle of quite a big storm system in the Atlantic at the moment. I'll be talking a little bit more about that later on in the video. But the reason, or one of the reasons anyway, well, there's two reasons. We've got ENSO neutral condition in the Pacific, and with rather an El Nino, because El Nino dampens down hurricane activity. So ENSO neutral there, and then we've got these warm sea surface temperature anomalies in the tropical Atlantic. Further north, now this area up here to the south of Greenland is quite interesting. That's been fairly cold over the past few years. We've been talking about the cold blob a lot in the North Atlantic, but it looks like that's going. Certainly at the moment, it's warming up quite a lot to the south of Greenland. So we aren't all that far from a tripod. If you watch these videos regularly, you'll know that a tripod is a three-way band of sort of warm, cool, and warm. So we've definitely got the warm there. We're warming up here. We haven't really got the cool in this central area just yet, but it certainly has edged more towards a tripole over the past month or so. In fact, I can show you the sea surface temperature anomalies in the Pacific and the Atlantic from the start of August. So that anomaly is the very latest one from the 31st of August from NOAA. This is the anomaly from the 3rd of August. Notice up here, much, much colder and not really quite as warm. It's fairly warm through the tropics, but not as warm as it is right now. So the Atlantic has changed quite a lot, you have to say, over the past month. And big changes in the Pacific as well, because we didn't really have all that much in the way of cold and average sea surface temperature anomalies through that equatorial part of the Pacific Ocean start of August, and you can see how those have developed through to the end of August. We'll be having a look much more in-depth through reanalysis at the ENSO state in the coming updates. We've got the SOI in for August. This is Southern Oscillation Index. Just talk you through a little bit what's happened with this through 2017. It's just an index that's reflecting the state of the atmosphere in the Southern Ocean, in the Southern Pacific Ocean. So it's not driving anything, it just tells you what the atmosphere is doing down there in the Southern Pacific Ocean. When the SOI is negative, it tells you that the atmosphere is in an El Nino state. When the SOI is positive, it tells you that the atmosphere in the Southern Ocean is in a La Nina state, a cold event state. So back through the earlier part of the year, we was around ENSO neutral there, but we went through to March and April. We saw quite a negative SOI number, minus 6.3 in April. At that point, everybody was thinking we was going to be going into El Nino. In fact, there was even talk about a super Nino. I'm sure you remember that. Also very negative in June as well, at minus 10.4. But after that, we went strongly positive through July at plus 8.1. So June, the atmosphere was reflective of El Nino, but July, the atmosphere in the Southern Ocean was reflective of La Nina. And that kind of like put the kibosh, if you like, on getting an El Nino going, because what you need to get an El Nino going is to get the SOI going more and more negative on a month-by-month basis through the summer and into the autumn. So quite obviously, the way we swang from that negative SOI in June to a positive SOI in July, that put the finish on the chance of an El Nino this year. Now, August SOI number is in, and it's still positive at plus 3.3, but less so than July. Interestingly, July coming out 8.1, August coming out with an SOI number of 3.3. So quite why we've seen so much cooling from the beginning of August to the end of August in that extra part of the Pacific Ocean, I'm not quite sure, because the SOI actually backed off a little bit from that La Nina signal in terms of the atmospheric setup in August. But nevertheless, whatever is going on with the SOI, quite clearly from the start of August to the beginning of August, we have seen a trend towards what looks like a bit of a La Nina signal, a bit of a cold event signal. So I think through reanalysis in the coming updates, we're either going to have to look at ENSO neutral winters again, or possibly even weak La Nina winters, and we covered a lot of this last year, so we're going to be going over ground that we discussed last year a little bit in some way, but that certainly seems to be the way we are trending at the moment. CFS-V2 is forecasting that we're going to drop down into La Nina territory. So these are the temperature anomalies on the side with the months along the bottom. And so to go into a La Nina, a cold event, we need to be under minus 0.5 degrees as the anomaly. We need to be at or under that over 5 tri-monthly periods. So that's like our minimum requirement just there, that line just there, to get a La Nina. You can quite clearly see that the model is going under that. It is going into genuine La Nina territory, albeit quite weak La Nina, although there are a few ensemble members that are actually going down into a moderate or even strong La Nina. But they're outliers. Let's concentrate on the black dash line. That black dash line, the sort of ensemble mean, that is going down into La Nina territory quite clearly, albeit it's weak La Nina territory. The caveat is that we probably aren't doing it over 5 tri-monthly periods. So you have to say from there, which is October, to around there when we start to recover, which I think is about March, that probably is 5 tri-monthly periods actually. So just about the CFS-V2 is forecasting that we're going to have a weak La Nina for the winter of 2017-18. We've got to think a little bit about that in subsequent updates in terms of looking at what that could mean. From last year's updates, when again we was looking at either ENSO neutral or weak La Nina, I think there was some evidence that weak La Nina can help to enhance a colder, or the risk of a colder than average winter for the UK and Europe. But we're going to have to go over that again, I think, in the coming updates. It will be an area that we explore further as we go on into these updates. We can't get everything crammed in, of course, at one go, because we've got 11, can you believe, 11 of these winter updates to do, as well as 3 season model roundups, and finally the winter forecast. So got a lot of updates to do, and we'll be discussing that much more in future updates. We'll just throw this in, the cold and warm episodes by season chart. Again, this is looking at ENSO region. We start off at 1950. It's got every tri-monthly ENSO period back to 1950, and we go right way down to the current year, which is 2017. Of course, we haven't got the latest number in the box for the most recent tri-monthly period. That will probably be appearing next week. But you see the idea what I'm talking about the 5 tri-monthly periods. So, for example, the last week La Nina was last winter. This one just here, where we have 1, 2, 3, 4, 5 tri-monthly periods. Taking those temperature anomalies down to or below 0.5 degrees below average. In fact, the first one comes out at 0.6 below average, 0.8 below average, 0.8 below average, 0.8 again below average, and then 0.7. So that's our 5 tri-monthly periods. We go under 0.5 degrees below average. So that is a designated La Nina, albeit an incredibly weak one. And that's the kind of level that CFS-V2 is at for the coming winter. We shall see whether we do indeed go into a weak La Nina for the winter. Of course, we're going to do reanalysis to show what that could mean. Right, next thing we're going to look at is the Atlantic hurricane season. As I say, this does tie in a little bit with what's going on in terms of those sea surf temperature anomalies in the Atlantic, because we're having quite a big hurricane season. This is the 2017 Atlantic hurricane season information page from Wicker Wikipedia, and we can see that so far, we can scroll down to the numbers, your important numbers. So far we've had 10 depressions, and we've had 9 storms, we've had 4 hurricanes, and 2 already category 3 or above, major hurricanes, category 3 or above. And it's very early in the season, actually. It's still only, what is it, day 2nd of September when I'm recording the video, 1st September when you're watching the video. So it's still very early days, and those are pretty big numbers already. So it makes you wonder where we'll be by the time we get through into the end of October. Now, the reason we look at hurricane activity is because there is a connection. This is a Joe Bastardi theory, the legendary forecaster from America. There's a connection between active hurricane seasons in the Atlantic, so large amounts of hurricanes and tropical storms, and possibly blocking in the subsequent winter. And the reason, I'll go back to this chart, because what a hurricane is doing, you've got all this heat down here, of course, in the tropical Atlantic Ocean. What a hurricane is doing, it's taking that heat that you have there, and it's essentially pushing it north. It can push it north that way, it can push it north that way, it can push it north that way, and of course it can also push it north that way. But whatever track it takes, the idea is that you're taking the heat out of the tropics, you're pushing it into mid-latitudes via areas of low pressure by a storm system. Eventually that's going to get dumped up in the pole. So it's a way that the Earth redistributes the heat, if you like. It's one of the Earth's thermostats at work. But when you get lots of heat being dumped into the pole via these storms, later on, that can translate back through feedback mechanisms into an increasing risk of northern blocking. So it's one of the things that we look at through the autumn, where we have a big Atlantic hurricane season, can be a pointer towards a chance of blocking and a colder winter. This is the current position in the Atlantic, so we're already up to I in terms of the named storms. We're up to Irma, which is, again, it's a category 3 hurricane. It's probably going to go up to category 4 or 5, and this is another disturbance just here that might develop into our next named tropical storm in a few days' time. We'll be keeping an eye on hurricane activity, of course. QBO next, quasi-biennial oscillation. We haven't had the update for August QBO number, but we can see quite clearly we are going into an easterly QBO. So on this chart, the grey areas are indicating westerly QBOs. The white areas, such as we have there, indicating easterly QBOs. Now, this is kind of like a reflection of the strength of the zonal westerlies. So when we have a westerly QBO, it tells us that the zonal westerlies in the northern hemisphere are going to be strong. They're going to be enhanced. So westerly QBOs tend to go with an increased chance, never guaranteeing weather, but an increased chance with westerly QBO of a milder than average winter. Easterly QBOs tend to have more blocking. They tend to have weaker westerlies. You weaken the zonal flow across the northern hemisphere, and an easterly QBO can sometimes, no guarantees ever in weather, but an easterly QBO can sometimes go with a colder than average winter. So, for example, the winter of 09-10, which was our last cold winter from start to finish, really, that was a easterly QBO winter, whereas the winter of 2013-2014 over here, that was very mild winter, of course, very stormy, wet winter. That was a westerly QBO. However, it's not quite that straightforward, because here, well, I've already highlighted it, we've got an easterly QBO in the winter of, I'm not sure what's happened there, so let's just get rid of that and start again. So for the easterly QBO during the winter of 2007-2008, just here, that's the easterly QBO, but it's a mild winter. 07-08 was a milder than average winter. So never a guarantee. This is where we are right now in terms of the ECQBO. We are developing into an ECQBO. We're going to be doing something a little bit like that in the coming months. So all this area will be white. And I think winter 2017-2018 is going to be a solid ECQBO winter. What we're going to have to do, again, probably through reanalysis, is see how much an easterly QBO enhances our chance of getting a cold and average winter. That will be something that will be coming up probably in the latter part of the updates, but we will go in depth into the QBO, the quasi-biennial oscillation, and we'll try to decipher just how much an ECQBO enhances our chance of a colder than average winter. So this is showing every month's QBO back to 1948. I thought I'd just throw this in because we're looking at this next week. We haven't had the number updated for August yet, but this is 2017 just here. We start off with a westerly QBO, which is indicated by a positive number, plus 14.92, and we have that in February and March as well. So those are solid westerly QBO months, and April also. May, it's a little bit less, but still very positive, so that's still a westerly QBO as well. But look at the flip that happens from May to June. We go from +8 in May to -3 in June. Very interesting how that happened. Very quick flip from a westerly into an ECQBO, and then that's strengthened in July at -10.48. This is where August number will be placed, and we'll have that for you next week. It should, right, if everything's working correctly with the atmosphere, it should be more negative than last month's number, than July's number. So it'll be very interesting when we get that QBO number for next week's update. It should be going more into the easterly phase of the QBO. Proper easterly QBO condition take us into sort of -21, -23, -25, that sort of number, and that's the kind of numbers we'll be expecting to see by the time you get through to the end of the year. One of the things we may look at as well later in the updates is whether a quick change from the westerly to the easterly QBO has any sort of influence on what might happen for winter, because that's a very quick flip that has occurred there from where we was in May at +8.1 to where we was in July, -10.48. Remember, these indexes, same with the SOI, same for QBO, same with the Arctic Oscillation, North Atlantic Oscillation, they're all just telling you what the atmosphere is doing. None of them are driving. So we have a look at solar activity next, and this is the latest in terms of the solar disk on our side of this today from solarham.net. We have got an increase in sunspot activity. We've got quite a big region just there. We've got another sunspot just there, and one over here as well. Quite a lot of activity, although Solarham is designating solar activity today as being at low levels, but there are quite a few sunspots, and this is showing you where we are in terms of the solar cycle. So we are going down quite solidly into solar minimum territory. If I just throw this up to sort of show you where we are in terms of the solar cycle. So this is where we begin with solar cycle number 24 just here. This is our first maximum solar cycle 24. This is our second maximum solar cycle 24, and then this is going down into solar minimum. True solar minimum occurs around here in around 18 months time. So we're at this sort of level now, which is a low level of sunspot and solar activity. We're at sort of 2010 levels, really 2010 being our last colder than average winter period, really. But remember, that is coming out of solar minimum and trying to get up to into the solar cycle, whereas this is coming down from solar maximum, so you can't really compare. But we are at a minimal level of solar activity in terms of the actual solar cycle. However, as I explained, we are seeing a bit of a tick up at the moment in terms of sunspot numbers. So this is the Gauss-Weatherford's winter update solar activity tracker. This is just updated as I speak, hot off the press from our good friend James Ackrill. And you'll be seeing this every week. We'll be tracking solar activity through the winter updates, see what's going to happen. We should see a decline in activity, but as we're declining, you can't rule out the chance of an upward spike. And that's what we're going through at the moment. So this is where we currently are in terms of the sunspot numbers. We have shifted those sunspot numbers up quite a bit in the last few days, and that has lifted up the trend lines actually, the thick green and the thick red, and also the thick pink line there. They're all going up at the moment, so we have seen an increase in solar activity. This should, because we're only 18 months away from true solar minimum, this should be quite a short-lived spike in activity. We should be doing something like that, so spiking up and then pushing down, and again what you see is spike up, then drop down again there, spike up, then drop down. So very quickly, I would assume by next week's second update, really, we should be seeing this going down again. This is telling us the daily sunspot numbers, of course, and these trend lines should start to move back downwards once again as well. The reason we look at solar activity is because we have minimum levels of solar activity. It can be one of the things that coincides with an increased risk of northern blocking. Now, this is quite interesting because it shows you where we are in terms of the solar cycle now, so cycle number 24, to where it was back in the old solar cycle number 12. I don't want to go in depth over this at the moment, but I will talk about this in a subsequent video a lot more. And if you've been following the winter updates over the past couple of years, you'll know about the connection between solar cycle 12 and solar cycle number 24, the current solar cycle. But I haven't got time really to go into that for this first update. But we will do an update that focuses specifically on solar activity, or primarily on solar activity. I just want to draw you to this area just here. This is last winter, 2016-2017, and its counterpart from solar cycle 12, which is the winter of 1886-1887. Now, for these two solar cycles, that is the 10th winter of those solar cycles. For the last solar cycle, for last winter, it was a mild winter. Its counterpart in solar cycle 12, 1886-1887, was a cold winter. So they deviated, 2 winters deviated for the 10th winter of these two solar cycles. Now we're at the 11th winter for solar cycle number 24, and that's going to be either somewhere here, or it will be somewhere here if it's a cold winter. Its counterpart, the 11th winter of solar cycle number 12, was the winter of 1887-1888. You see, again, it was a cold winter. What we're going to do in a subsequent update is have a look at, through reanalysis, at the 11th winter of every solar cycle going back to this one, going back to solar cycle number 12. So we'll look at the 11th winter of all solar cycles from solar cycle 12 to the last solar cycle, number 23, to see whether there is any sort of connection between this point of the solar cycle that we're currently in for number 24 and the other winters that occurred around this point of their solar cycles, the 11th winters of the solar cycles. That's going to be coming up in a future update. Right, let's deal with Siberian snow cover, which we won't be talking about for very long, and also Arctic sea ice. So this is from this time last year. This is from the 1st of September 2016. This yellow area is the Arctic and its Arctic sea ice. So at this point last year, it was well into the melt season of 2016. Notice in Siberia, we had got a little bit of snow, a few splodges, as I call them, of snow over in the far east of Siberia, but otherwise pretty much snow-free. I'm going to show you the very latest in terms of Arctic sea ice, and Siberian snow cover. So this is it. Again, we see that we have had quite a big melt season. Quite honestly, there's still a lot of yellow, but there is a lot of blue. I'll change the highlighter. So there's still a lot of blue, which is where the Arctic sea ice has melted. All this area is sort of meltwater from where we had ice earlier in the season. It's all melted away. It'll refreeze in a few weeks' time. And then not much going on in terms of snow cover yet across Russia or Siberia. Again, I've got a few little splodges here and there, quite early really to be seeing those. But that's going to be much more impactful when we get through to the end of September and October, because eventually all of this from over here right to over here between September and the start of November, all of this will fill up with snow, and how quickly that happens is one of the things that we look at later on in the season. At the moment it's too early to get much snow cover. Let's see how Arctic sea ice is doing in comparison to previous years. So I'm going to put 2017 in now. This, by the way, is the interactive sea ice graph. So I'm going to put 2017 in, which is just here. You can see it with this blue line. The grey line, by the way, is the average. So you can quite clearly see, again, and it has been another big melt season. We saw that from the image that I just showed you in terms of Arctic sea ice extent. It has obviously been a big melt season. Again, that's where we are right now in terms of Arctic sea ice coverage. So obviously we're under average, we're under trend, another big melt season. But how big has the melt season been this year? So I want to go back to a long time ago. We go right way back to 1979. I did go for every year with these last year. I won't do that again, but I'm going to go back to one year in the early 80s. I'm going to pick it at random. Let's try 1985. You can see that the year of 1985 was very much on trend in terms of the average. So you can see how much under 1985 we are for this year. But let's start filling it up with more sort of recent years. So let's start with 2007. And you can see we are on a par really with 2007. That blue line there is 2007. What about 2008? So again, we're on a par really with 2008. 2009 was a slightly better year in terms of Arctic sea ice extent. 2010, we were a little bit under 2010. Really. 2011, yes, we're on a par with 2011. Let's carry on filling things up further. 2013, I think we're probably on a par with 2013, maybe a little bit under that, and possibly a little bit under 2014 as well. Of course, the more years we're adding, harder it is to see our year. 2015, yes, I think we're on a par with 2015. And then that brings us to last year, 2016, and I'll put that one in now. And again, I think we are on a par with 2016. In fact, let's get rid of some of those years and just have 2016. So get rid of that, and also let's get rid of that year, and that year, and that leaves us. And we'll also get rid of 1985. So that leaves us just with 2016 last year and 2017. You see we are very much on a par with 2016 in terms of that blue line and in terms of the red line. And that leaves just one more year to fill in, and that's 2012, which is known as the death spiral. This is the lowest ever recorded year for Arctic sea ice coverage in the melt season. So let's put 2012 in now and see how close we are to the death spiral. And you can see what's happened earlier on, and we're going to get rid of last year. You can see what's happened earlier on in the melt season. We was running close to the death spiral of 2012, but now we have branched away from it. That's where we are for this year's melt season. This green dashed line is 2012. Quite clearly, we have broken away from 2012. We aren't going to get a death spiral. We'll be reaching our minimum Arctic sea ice extent in the next couple of weeks. It would take a lot to get down to 2012. That's not going to happen. So we're not going to beat 2012 in terms of Arctic sea ice loss for this melt season. But we've already established it has been another big melt season. It's on a par with several of the years that have occurred since 2007. There is a connection between years that have big melt seasons and possibly more winter blocking, although it hasn't worked out really over the past 2 or 3 winters all that well. Have more on that next week as we get closer to the minimum Arctic sea ice extent. And then I just want to talk a little bit about analogues. So I'm going to have a look at some analogues next to round off this first update for you. Going to look at front-loaded summers. So this was an important issue when we did the autumn forecast. The analogues we used were looking at front-loaded summers, or summers that are warmer and more high-pressure dominated in the early part of the summer, what that could mean for the autumn. We're going to follow that through now for the winter updates. So you can see what happened through this summer. It's a little bit controversial because Scotland never joined in with this front-loaded summer, but we did have a warm start to the summer of 2017 down across England and Wales. This is the central England temperature. You can see that for June the CET came out at 16.0, an anomaly of 1.9 degrees above average, but by August we was actually cooler than June, which is quite unusual. 15.6 was the central England temperature for August, a little bit cooler than average. So quite clearly it was warmer in the early part of the summer when it turned cooler later on. That's for England and Wales. It doesn't really apply for Scotland, but I just wanted to follow this through. So if you watch the autumn updates, you'll know that we did have a look at front-loaded summers and what that could mean for the autumn. We're going to follow this through now for the winter. So our good friend James Ackrill has been doing more re-analysis for us. And what we're starting with for this first update, we're going to have this over a couple of weeks. The first update for the winter is looking at front-loaded summers from a temperature perspective, because if you watch the autumn updates, you'll know you can either look at this in 2 ways. You can either look at it in terms of temperature, being front-loaded with temperatures, or in terms of being front-loaded with high pressure. Sometimes they overlap. Some of the summers they did overlap, but not all of the summers. So we start off with temperature, front-loaded summers in terms of temperature for this first winter update. And our first winter that we're looking at that follows a front-loaded summer in terms of being warmer in the earlier summer is the winter of 1896, 1897. And that one's placing a deep trough of low pressure around the west of Europe. Have got quite a lot of blocking, actually, interestingly, up over the polar field. At times, I think this would have been quite cold, but not all the time. It's not a classically cold setup, but I would assume that would have brought some cold conditions at times through the winter of 1896, 1897. Our next winter is 1917, 1918. Remember, again, this is following front-loaded summers from a temperature perspective. So this winter has quite a lot of blocking to south of Greenland. Then it has low pressure up here. There is a fly in the ointment with above average heights to the south and the southeast, doing something a bit like that with flow and the jet stream. There was some cold weather through the winter of 1917, 1918. Wasn't as cold as the winter before it though, 1916, 1917. Our next winter following a front-loaded summer from a temperature perspective is that of 1925, 1926. This one just looks very unsettled. Lots of low pressure in the Atlantic, bringing the jet stream through like that. That just looks a really wet, unsettled, and probably fairly mild winter as well. Winter of 1930, 1931 also looks very unsettled. There appears to be a trend for these to be unsettled winters, certainly before 1950 anyway. Big trough there through the west of Europe and through the UK as well. Then we've got a ridge through the middle part of the Atlantic, doing something a bit like that with the flow and with the jet stream. At times that could have been quite cold. Winter of 1930, 1931. The main thing though is that it would have been very unsettled. This is a classic winter. This is 1940, 1941. This is all perfectly lined up to deliver us a very cold winter. So we've got lots of low pressure, below average heights to our south. We've got all of this blocking here centering around Greenland, and we're able to tap in to very cold air from the east and the northeast. That was a really cold winter, severe winter, the winter of 1940, 1941, following a warmer than average front-loaded summer. The next winter is 1950-1951. This is another cold one. It doesn't look all that classic. We've got a below average heights over the UK and the west of Europe. Notice again a ridge through the central part of the Atlantic, not quite making up towards Greenland, doing something like that with the flow and the jet stream. That was a front-loaded winter following the front-loaded summer. It had a very cold December with quite a lot of snow. I mean, it moderated in January and February, in some ways similar to December 2010 and then January and February 2011, although not anywhere near as extremely cold as December 2010. But the same idea, cold in December, then moderating later on. So far, these analogues aren't too bad, I have to say, if you want colder weather this winter. Our next winter is 1957-1958. Following the front-loaded summer of 1957. This is quite a cold winter as well. So we have a deep trough to our east and northeast. Again, a ridge through the Atlantic heading up towards Greenland. That seemed to be quite a regular feature, doing something a bit like that with the flow and the jet stream. No Scandinavian highs yet in any of these analogues, you'll notice. If there is blocking, it's usually in the northern Atlantic and around Greenland. That one started off mild in December, then got progressively colder through the first months of 1958. 1960-1961 next, and this one just looks very unsettled, really, bringing the jet stream through the country like that. That's just a really unsettled winter in 1960-1961, one of the milder winters of the 1960s. Then a long gap, funnily enough. You have a very long run to 1992-1993, and this one very, very anti-cyclonic winter. This is completely different to anything that we've seen so far. Up to this point, most of the winters we've looked at have either been quite cool, but the main thing has been very unsettled. This one really high pressure dominated, so it's through the Atlantic into much of Europe. Below average heights are up to the north, with the jet stream up to the north as well. If that was a summer pattern, that would be a very hot summer, but it's a winter pattern. So the winter of 92-93 was generally just a really quiet, mild winter. It was cold in December, but it's sort of the inversion. Cold, not classic, Arctic, snowy, cold, very dry and quiet winter, 92-93. Then go through to 93-94, interestingly, for our next analogue of a front of a winter following a warmer than average front-loaded summer. This one is very unsettled, deep trough over country. There was some cold snaps, excuse me, in the winter of 93-94, but it isn't remembered particularly as a cold winter. We're coming towards the end now. We go through to the winter 2006-2007. That one looking very unsettled. That was an unsettled winter, bringing the flow through like that. Notice this nasty ridge, nasty from a cold perspective across much of Europe. So that was a very mild winter, quite wet, particularly so in the north and west, the winter of 2006-2007. 2010-2011 is in there as well, interestingly. So it doesn't look all that dramatic, does it? But we know that this includes a real December to remember. And for the 3 monthly reanalysis, we have got still a blocking signal there to our north, with below average heights to the south. Of course, all of the interest in that winter was on December 2010, but December to remember, and is kind of similar, as I say, to the winter of 1950-1951. 2015 is our final year, winter 2014-2015. This one, let's change the colour again. So we've got quite a big ridge there in the Atlantic, below average heights up to the north, and bringing the flow in from the northwest. That was near average with the temperatures, actually, and quite unsettled up to the north, winter 2014-2015. If we combine all these years together back to 1951, so pre-1950 if you like, this is what the signal is. It's not too bad if you want cold conditions, because we've got this ridge through the northern Atlantic, sometimes, not every year, but sometimes getting up towards Greenland, and that places the trough over the UK and across western parts of Europe as well. We do something a bit like that with the flow and with the jet stream. So not every year is guaranteed to be cold by any means, but there are quite a few years within that package that are colder. And then if we have a look at all years combined, this takes us back, right way back to 1897, the first winter we started with, and it runs us up, not quite to 2015, but we do run up to 2011 with this all years combined chart. And this looks better, actually, from a cold perspective, if we include those pre-1950 years. Going back into the Victorian era, we find that we place a deep trough there across the UK, and it's better for blocking, with the blocking generally centred up towards Greenland. And again, we're doing something like that with the flow. Only a subtle difference between the two combined charts, but that one definitely is better if you want colder than average conditions. So I think there is a clear signal there for the winters that follow front-loaded summers from a temperature perspective to be certainly unsettled. The only really settled one we have throughout all of that was 93. Otherwise, very strong signal for an unsettled winter. Just the placement of the trough and the ridge is the uncertain factor. But overall, probably not too bad an analogues package from a cold perspective. Next week, we're going to have more on this, because we'll be looking at analogues that follow, again, they're following front-loaded summers, but this time from a high-pressure perspective, an anticyclonic front-loaded summer, which doesn't necessarily connect to temperatures. Some years did overlap, we know that from the autumn updates, but not every year overlapped. Right, I think that's enough for the first update. There's just one more thing left to do, and that's to give you the day we're going to release the winter 2017-2018 forecast. I'm just going to get that up for you now from my calendar. And so we've gone down to September, so let's go back to December. That didn't quite work out, did it? So this, anyway, is the day that we're going to be releasing the GavsWeathers.com winter 2017-2018 forecast. I've already put it in my diary. I hope you'll be putting it in your diaries too. It's going to be Sunday, the 3rd of December. Usually I release it on the 1st, but I've decided to delay it just a couple of days this year. So it will be released a little bit later than usual on Sunday, the 3rd of December. That's when we'll be releasing the GavsWeathers.com winter 2017-winter 2018 forecast. Hope you'll put it in your diary, and I hope that you'll keep checking back to all of the updates that we do between now and then. As I say, we've got 11, well, after this, we've got 10 of these winter updates to do, 10 more, as well as 3 season model roundups. And then we get certainly the 3rd of December, and we'll release the GavsWeathers.com winter 2017-18 forecast. Right, 47 minutes for update 1. I'll try and get the some of the other updates to be a little bit shorter for you. This one's probably been a bit too long. Sorry about that. So update 2 will be with you this time next week, same time, same place. Hope you'll come back for the next instalment then. Then this will be placed on the winter updates and forecast page with a written report, so you can come back and watch the video whenever you want. You'll also be able to read that written report later, probably around 7 o'clock this evening, something like that. But that's all for now. Thanks for watching.